All right, so again, delta G is negative for a spontaneous process. And by simply looking at the equation here for the change in Gibbs free energy, we know that there are three variables, right? Three factors that will affect the value of delta G. There's enthalpy, entropy, and temperature. So make sure you know this, these three variables. So how would delta G be affected by the change in the values of these three factors, right? So let's say, for example, delta H is a negative value, right? Delta S is positive. How would delta G be affected? What would be the sign of delta G? So again, if delta G or if delta H is negative and we're subtracting a positive value here, T times positive, what would the value of delta G be? Is it going to be a negative value or a positive value? Right, because you're subtracting a positive. Negative minus a positive is always going to be a negative value, regardless of the value of T, right, the temperature. So negative at all temperatures. So if it's negative at all temperatures, that means that it's spontaneous, right? It will never be non-spontaneous. All right, what about when delta S is negative, right? So basically both negatives here. If we have negative delta H minus T times negative delta S, then we have, so delta G will be dependent upon the temperature, okay? So a negative minus T times a negative, right? So if this value right here is a large number, if we have a large number, then delta G is going to be positive, okay? But if we have a small t value, then it's going to be negative. All right, so it's negative at low temperatures, but positive at high temperatures. All right, let's look at another scenario here. Now, let's say we have a positive delta H. So that means it's an endothermic reaction or an endothermic process. And delta S is negative for the system. Okay, so if this is positive, and then we're subtracting T times a negative value. Okay. So in that case, a negative or minus a negative gives you a positive, right? So a positive plus a positive will always give you a positive value. So delta G is going to be positive at all temperatures. All right, so for the last example here, what if we have both positive delta H and positive delta S? So this is a positive value here, and so you're subtracting T times a positive value. Now this will again depend on the value of T, right, the temperature. So if this value right here gives you, or if the temperature is high, right, then the delta G is going to be negative, okay? And if temperature is low, then that will give you a positive delta G. Okay. So here's my question. What if delta G is equivalent to 0? Would that be spontaneous or non-spontaneous?
It's neither. It'll be equivalent.
Right, it's neither spontaneous nor non-spontaneous. Because, as Mara said, it would be at equilibrium. Right, so any equilibrium reactions or processes will give a delta G equal to 0. Okay, neither spontaneous nor non-spontaneous. All right, so let's take a look at this table right here, table 18.1. It basically shows you several examples of actual chemical reactions and how that affects the value of delta G. So we're looking at the different values of delta H, delta S, and T, and how that affects spontaneity. All right, so I'm just going to show you the first two examples here. So this one and this one right here. So if you look at the first chemical reaction equation here, we have 2 moles of dinitrogen monoxide breaking down into 2 moles of nitrogen gas and 1 mole of oxygen gas, right? So can you determine the delta S of the system for this specific reaction? Would it be a positive or a negative? Anyone disagree? It's going to be positive because we have an increase in number of moles, right? From 2 moles to 3 moles. All right, and that's also what's written here. Okay. So we have a positive delta S, and this decomposition reaction is actually exothermic. So there's a net release of heat, and that will give you a negative delta H. And so if delta H is negative, right, and delta S is positive, if you plug that into this equation, a negative here minus a positive, that will give you a value of delta G that's always going to be negative regardless of the value of T.
So like would you give, what information out of all of those information would you give like on the exam? Like do you prepare, know how to study?
All right, so for the second example here, we have 3 moles of oxygen gas, right? So we're converting oxygen gas into ozone. So we have 3 moles of oxygen gas to 2 moles of ozone, and that gives you a negative delta S for the system. Right, so for this one, we have negative delta S, right, from 3 moles to 2 moles. Okay, so we have a negative delta S here, and because we're converting from oxygen gas to ozone, that requires energy, so it's an endothermic process. So you have a positive and a negative. I think I forgot to mention earlier, so when delta G is less than 0, then it'll be a spontaneous process regardless of temperature, for the first example. All right, for the second example here, it'll always be a positive delta G. All right, again, if we plug it into that equation, all right, if this was a positive value and you're subtracting a negative value, then that's basically an addition plus, right, a positive value plus another positive value. So it's always going to be positive. And so this example, specific example, will always be non-spontaneous regardless of temperature. Let's take a look at this one example here. Consider the reaction for the decomposition of carbon tetrachloride gas into graphite and chloride gas, right? It gives you the value of delta H, change in enthalpy, which is positive. It also gives you a value of delta S, change in entropy, which is also positive, right? But notice that the units here, they're not exactly equal, right? So we have kilojoules, and this one is joules per Kelvin. So keep an eye on the units always. So part A, calculate delta G at 25 degrees Celsius and determine whether the reaction is spontaneous. All right, so we know the equation for delta G. So delta G is equivalent to delta H minus T delta S, right? And we know the delta H value here is 95.7 kilojoules. And then we're going to subtract temperature times delta S. But first we have to convert degrees Celsius into kelvins, so 25 plus 273 gives us 298 kelvins. And this is multiplied by delta S. So first we have to convert joules to kilojoules. So all you have to do is divide this by 1,000. So 0.1422 kilojoules per Kelvin. So you can see that kelvins will cancel here. And this gives us 53.3 kilojoules. All right, so as you can see, this is a positive value, right? Delta G is greater than 0. And so is this spontaneous or non-spontaneous?
Non-spontaneous.
Non-spontaneous. So that means it requires energy to happen, to occur. All right. So for part B, it says if the reaction is non-spontaneous at 25 degrees Celsius, determine at what temperature, if any, the reaction becomes spontaneous.
Delta H was positive. Or negative.
Well, what determines spontaneity when it comes to delta G?
I guess delta is.
Temperature.
What should be the sign of delta G?
Oh, negative.
Oh, negative.
Negative, right? So we're going to set delta G less than 0, right? So delta G less than 0 will be spontaneous. All right, and then we just plug this into the equation. So delta H minus T delta S is less than 0. So when this is less than 0, then we have a spontaneous process. But we want to find out what the temperature is, right? So we have to isolate T. So negative T delta S is less than 0, so we get negative delta H here. Okay. And then I'm going to divide negative delta S on both sides of the equal sign, or of the sign here. Oops. And you can see that the negative sign will cancel here, will cancel here. Delta S will cancel as well. And what happens to this less than sign when you divide a negative value? It flips. So now T is greater than delta H over delta S. All right, so our delta H is 95.7 kilojoules. And we're going to divide this by delta S in kilojoules per Kelvin. So that's 0.1422 kilojoules per Kelvin. And that gives us 673 kelvins. So that means that above this temperature, 673, then we will have spontaneous process. Okay. And below this temperature, below 673, we will have non-spontaneous process. What about at this temperature?
It's going to be at equilibrium, so neither.
Delta G is going to be 0, so it's neither, right? All right, let's take another look at another example. Which statement is true regarding sublimation of dry ice? All right, so sublimation is from solid directly to gas, bypassing the liquid phase, right? So we have sublimation here, so from solid to gas, right? What would be the symbol or the sign of delta S here? Is it going to be positive or negative? So from solid to gas, there's going to be an increase in entropy, so the delta S of the system is going to be positive. What about for delta H?
Depends on the equation, no?
Well, it's right here. We have solid turning into gas. Would this require an input of energy, or will there be a release of energy?
Release.
Yeah. No input.
There would be
because
an
if it's got to turn into gas, it's like boiling water. You have to use
Exactly.
gas.
So this will require energy, right? It's kind of like melting solid to liquid, but for this example, we're bypassing the liquid phase. So delta H system will be positive. So we have an endothermic process here. And so now you can just use process of elimination here. All right, so we have delta H positive, and delta S is also positive. All the other ones are wrong.
But I thought that sublimation didn't require energy because it's like,
Yeah, it doesn't require energy. Well, at specific temperature, right? So if we have, let's say, standard conditions, room temperature, you just leave it out, then that piece of dry ice will just spontaneously turn into gas.